All right, then let's wrap up what we learned in this section and a little bit also from the previous section, because sometimes it's just good to get the theoretical background as well. And I'll try to make this short and sweet so you can continue with the actual project. Let's talk about functions, visibility, what we haven't really talked about, constructor and the fallback function, as well as address and payable stuff. So the first one that I just want to recap is their setter and getter functions. Writing transactions means it needs an actual transaction that is mined, and a reading transaction is actually called a call, and that is only against your local blockchain node. Remember that everyone in the network has a copy of the blockchain, so you don't need to send a transaction to somebody else. You can just read it from your local cache, basically. And if you don't need to change anything, you don't need to inform anybody about that you were reading something. And reading is virtually free. It still needs gas, but you don't really pay it. You just pay it for yourself, so you don't need to pay any ETH. And yeah, that's it. So writing and reading transactions. Then there are view and pure functions. In earlier versions of Solidity, it was called a constant function. That is now view and pure for a while. So I don't think that anybody still remembers constant functions. That was, I think, from Solidity 4 or something. The view function reads from state and from other view functions. A pure function cannot read or modify the state at all, and it can only read like the variables that you gave it as a parameter or other pure functions. So it doesn't even touch the state. It has a couple of internal reasons from the EVM, which I'm not touching on yet, which we are going to dig into a little bit later. Now, the function visibility is something that we have not discussed yet. I just want to quickly mention it. There is public functions, which we saw already. We use them, public functions. You can call them from outside. There's also private functions, which can only be called from the contract itself. So you can have a couple of functions. If you want to structure your code differently, you can have functions that cannot be called from outside, that can only be called from inside. And you will love these functions once you hit an exception called stack too deep. Now, if you hit stack too deep, remember there's also private functions where you can get logic from a function which became fairly big. You can structure differently into other functions. It's not important right now, and I'm going to show you once we hit a stack too deep problem how we can overcome this. There's external functions which can only be called from other contracts or called externally with an actual transaction. They cannot be called from within the smart contract. And there's internal functions that can only be called from the contract, or, which we will see later, also from derived contracts. So when we talk about inheritance, then I will show you what internal functions are. They can't be invoked by a transaction from an account. There's a constructor. It's a function with the name constructor. It's only called during deployment, and it can't be called afterwards. And it is, now it's public. It was public or internal before. Now it's simply public. It doesn't need a visibility specifier at all. Then we talked about the fallback function. The fallback function is a function with the name fallback external and maybe payable to receive ETH or to receive call data that cannot be matched to any other function signature. And a function with the name receive external payable is there to receive a value without call data. And if you have both, then fallback will be called with call data and receive will be called without call data. This one can only be external, and the fallback function, the payable modifier, is optional. So if you don't have a payable modifier, then you're actually just catching calls to the smart contract that were meant against a different function signature that cannot be found. Contracts receiving values without a fallback function and without a proper function call to a function that is payable will throw an exception. The thing is, you cannot completely avoid receiving Ether. So there is a minor reward, which we haven't talked about, but definitely self-destruct. You can forcefully credit Ether to a smart contract by self-destructing a smart contract, which had a balance or a value stored on the address, and then you can use the beneficiary as this address over here, this beneficiary, you can set the smart contract that is actually not allowed to receive any ether, but it will still receive ether. That's a design from the EVM, which cannot be circumvented. So be careful if you have some kind of internal bookkeeping that relies on the balance of the address of the smart contract and how many ETH were sent there through legitimate functions. If that doesn't add up, that can happen, that you can forcefully send ether to there. Why I am talking so much about it, because there was actually a bug that cost someone quite a lot of money, because the internal functions then blocked any kind of withdrawal because the internal bookkeeping did not add up anymore. Also, when you send or when you use the fallback function or the receive function, then you can only rely on 2300 gas. That happens if you send to the contract with the transfer function something. It doesn't matter if it's 1 ETH or less or more. Then this will only send 2300 gas along. This is called the gas stipend. That's the 2300 gas. One thing that we haven't really talked about yet is the exceptions with require and assert. So that are exceptions. They became a fairly large topic because now you can have some sort of rudimentary try catch, which you couldn't do before. And you can even have named exceptions now, which you also couldn't do before. So I want to dedicate a lecture to that. But essentially this require statement over here will error out, will make the complete transaction, reverse the complete transaction if this statement doesn't evaluate or evaluates to false. So if the message data, a property that we haven't really talked about yet, but this is the call data that was sent along, like value, like message sender, that's the data that was sent along, is not 0, then you can like forcefully throw an exception there so that the transaction will revert. Then we quickly talked about message value and address. The global message object contains not only a sender, but also a value property, and that is in way. And the question is how much way was sent during this call. And that means, again, like before we had it with message sender, if an address A sends to a contract 1 ETH, and that contract 1 sends to a contract 2, I don't know, 0.5 ETH. So if this one sends 0.5 ETH here, then over here, the message value will be 0.5 ETH. And if this one sends over here 1 ETH, sorry, my handwriting, then over here the message value will be 1 ETH. So it depends on where you are calling message value, from which point of view. So this point of view is that this contract initiated this kind of call, and over here it will be then 0.5 ETH, and this contract sees this address here as the initiator, and this one will be 1 ETH. Very important to understand is every kind of address type variable, so any kind of variable that is of the type address, will have a balance. So you can always call in any smart contract for any address, you can read the balance. And why is that? Because all of the information on the blockchain is publicly available. An address type can be payable, so you actually would have to define this as a payable modifier on the actual variable type. Payable addresses can receive a value, so that would be if this would be an address payable variable named x, then you can do x.transfer, and that one is in way. It's not an ETH. And the contract itself can, of course, also have a balance. And the question is, how do you get the contract address? That is by calling address this. That would be the address of the contract where it actually sits, and then you can call the balance and get the balance in way. All right, that's it, what I wanted to talk about. What are the key takeaways here? Constructor is called only once and once only, that is during deployment. The fallback function is here to receive ether as a simple transaction, but beware of the gas limit. The getter functions are usually view functions, so you can safely usually assume that it's a view function. View and pure is only against your local blockchain node, doesn't need mining, doesn't really cost anything, and there is a payable address, and addresses have a balance. All right, I will see you in the next lecture.